Yeah, so as I was talking about use spice, there are various spice are available. So it will not take much time. So I thought I'll talk about spice today itself, and then you can use it wherever it's required. It's required. So maybe in your if you are using Windows or if you are using Linux, the look will be a little bit different than what you are seeing here. There is something called LT Spice. Please use LT Spice. This is by a company called Linear Transform. So you can use that LT Spice. That L and T is from there. Otherwise, this is a spice simulator. The spice also has some full form. It is for some circuit simulation kind of thing. So you can look it in Wikipedia. But spice has all the meaning. SPICE. Some environment. E stands for environment. C stands for some circuit. Right? Yeah. Dinesh, is it? Do you remember this spice full form? Yeah. So it has some. All these things are there. So if you are going to open it, you can create a new maybe. So in actually MacBook it looks not so much good, but if you are going to open your window or Linux, all the tools are on top. However, if you want to use it, let's say if you are using Mac, and or if you want to use your own window or Linux, you can have all those tools from doing the right click. On right click, you will have something called draft, and you want to add some component. So now, as this simulator has been made by LT, means Linear Transforms company. So what they have given, all the components which they are designing, it has been given to you. You can read it, right? So various components like ADCs, analog to digital converter, comparators, digital to analog converters, some digital part like some gates, filter products, miscellaneous, operational amplifiers. You must be knowing that there are many kinds of op amps are available in the market. It's not only 741, and 741 is made by some different company. It is not made by LT, so you may not find 741 in this list. However, you can see there are different kinds of op amps are available. And during the time like when I was in BTech and I want to make, let's say, some project, which project will have all the ICs will be there. Like I made the project where I know that here I need 741, some place I need some resistance capacitor, and rest of the many ICs are there, let's say 555 timer IC. So what we used to do at that time, we used to get all these ICs. So these are the real ICs with all the real things already kept there. So just you can read here like it's a 8549, that's precision low cost HS by FET dual op amp. So all will have different functionality. There is something like precision low cost HS by FET. Then there is something like AD8031 2.7 volt 80 megahertz rail to rail op amp. So different op amps will have different application. Some people want input offset voltage of 1 microvolt. So similarly, like there are almost like if I am not wrong, 1,000 op amps are available, which are available in market, which can be used for some small hobby projects. So if you wish, like if you are, let's say if you are doing some let's say DP project or maybe some robotics project, if there is some electronics component and if you wish to simulate it, you can simulate with the real block from here. Even one more thing, on top of this all the linear transform op amps, you can add other op amps also or other circuit components like TI, Intel. So those are also making some of the components. Those can be downloaded from internet and it can be added here. So you can increase the library for your future. Let's say if you want to make some project which is of power electronics and you need some H breeze IC, right? You know about H breeze drivers. Okay. So for all the motors, you need one IC which is going to drive that, which is known as H bridge IC, right? So that H bridge IC has some number. So that number you can Google it, you can find it out, and you can add it in this library. The earlier name of this entire thing, LT Spice, was Orchid. Now Orchid has been purchased by Cadence, and it's no more open source. However, this Spice, like LT Spice, it's open source. It does not require any money or anything, but it's like it will solve all your problems. If you want to simulate some circuit at the elementary level, you can do that. So let's assume that I'm taking some op amp which is of, let's say, JFET. JFET is junction field effect transistor. It's a kind of transistor which is like maybe in future you will learn it. So, but right now we are looking at the system level. So we can see here there are actually five different inputs are there. One is output, two are input, and plus and minus are supply, right? So you need to look at the those values in the data sheet of like you need to google it with LT1058 data sheet. This is what you need to write down. So you will find out the entire data sheet, that how much supply voltage you can give here, how much input is possible, what is the input offset voltage, slew rate, other things are there. This will be already there, right? So this way you can add any component. So right now I added only just one component, which is op amp. I may use, let's say, resistance. So resistance is a normal one which we can take it like res. With control R you can rotate it. So any number of time, if you want to rotate, you can rotate it. You can keep that. Similar to that, you can have one more component which is coming from draft. I'm, I'm drawing some random circuit. Now I want to connect them with the wires. So if I want to connect the wires, I can use this. Generally, I remember all the hotkeys like F3, F2, and F5. But like at the beginning, you can look at this. By the way, this particular window is coming from doing the right click. In draft, you can find out the wires. Then you can draw the connection between one place to another place. It's exactly similar to what you people have studied in maybe Cadence, Nikita, Mahima, and Divya. But that one is paid one, so it will be better than this one for sure, right? Now, if you wish to add somewhere ground, then you need to go to that particular net. You have to make the right click, and you have to label that net, and you can connect it to the first, which is ground. That will be here. So this net is connected to ground. If you want to make some changes like drag or move, or let's say I want to move it, I can move it here. Now similarly, here I can make two more nets whose names I'm going to give as, let's say, VCC and VE. So I'm giving these names. Earlier I gave the ground, now I'm giving something called VCC, and this net I am going to call it as VEE. Now this VCC and VE are the supply voltage. I am going to connect it through some supplies which can be found again in components. In components, you have to go to voltage. If you wish to connect the voltage, you have to use voltage. And while doing this, here I can give, say, ground. I'm going to give this net name as VCC. So in electronics, if I am giving the name like VCC here, so both the nets will be connected or they are tied together, right? The most important part is how much supply voltage do I need to give. For that, you need to go to the source of the voltage. You need to do the right click and you have to go to something called advance. In advance, you have plenty of voltage sources available, like it may be DC, pulse, sine, exponential, PWL, all are available. So for the first one, we need DC value. Let's assume that it's 15 volt, right? So this means that this VCC is connected to plus 15 volt DC supply voltage. Similarly, I want VEE to be connected to minus 15 volt. In that case, I can duplicate this with reverse polarity, and I am going to connect this one with VEE. So I'll give this name as VEE, and I have to connect this one with ground. Right, so now this supply voltage is connected. Now I need to give some input also. So I can add input by the components. In that again I need voltage. Right. So here again I can give the input. So right now I need, let's assume that I want to do some transient or AC analysis, then I need some sine wave, right? Not